Hello, we are NAE Group 60 and my name is Jason Wynn. My other group members are Joshua, Rex, Mitchell, and Omar, and our group is focusing on clean water for our project. According to the U.S. Geological Survey, the average American uses about 80 to 100 gallons each day, while the estimated minimum requirement for drinking, washing, and cooking is about 2 to 4 gallons per day. In third world countries, water is a difficult challenge. Many do not have the luxury of 80 to 100 gallons each day, as many families lack adequate access to clean water and basic sanitation. Regions such as Northern Africa and the Middle East suffer from these conditions. There are also regions that suffer from economic water scarcity, such as Central Africa. These places lack the economic means to be able to access clean water. There are thousands of deaths each day due to unclean water. Solving this problem is one of the biggest engineering challenges that exist today. While there is a lot of water in the world, much of this is unsafe to drink. Our role as engineers is to be able to filter and provide clean water to these regions in need. Our program allows the user to learn about different types of water filtration methods available in the world today. With water filtration, UV and chemical treatment, and desalination, the user is able to learn about different types of filters, learning about what type of biological and organic contaminants can be removed. There's also flow rate, setup difficulty, and several other details in our program as well. Our program also allows the user to test the economic costs of some of the filters, as well as examine some of their advantages and disadvantages. It also provides an Excel document that allows them to reflect their selections made in the program.
Our idea was to come up with a formatted display of filter information to inform the user and companies of various filter types. We started off the code importing our data using the respective Excel files. These are the following Excel files that we used. The first Excel doc contains the labels for our filter information. It includes filter type, biological, organic, and inorganic contaminants removed, flow rate, useful life, unit, filter, labor demands, setup skill, and maintenance. The next three Excel documents have filters respective to each category of water filtration treatment, UV radiation, and chemical treatment and desalination and arsenic removal. This information was found from the Meridian Institute. The repeater variable enables the user to repeat and select another filter. Part 1 try allows us to display all of the filter data on a new Excel file, filter selected info. We use a switch statement to keep track of the filter name provided the user's input from the menu screen. We created a user input variable to data validate for the filtration method selection. This would then change the string variable displayed in the following output. If the user ever tries to exit out of the program, they will be prompted with a warning and asked for another attempt for submission. User selection enters a function which collects data for a UI output. The scroll-down menu allows the user to access a variety of filter types for that specific type of filter. If the user wishes to return back to the filter selection screen, the user may select the back button. This filter information will then be reflected in filter selected info as stated previously and prints out a table with the respective filter information. In another while loop, we enter a new repeat variable in case the user wishes to enter multiple tries. Here, we ask the user to select a filtration method and an integer input for literage. If literage is not a positive number, the absolute value will be taken. We then organize the filter information into an array, first masking them appropriately for size for concatenation. This information is then recorded into a table. In addition to the formatted table output, we further organize this data for easy access in the Excel file. In addition to the Excel file, we decided to display a graph to show the true price range of the filter variable given the literage amount the user originally entered. This program can be useful for an introduction to some of the many water filters that exist today. It also allows the user to calculate a variety of different water filters available. Running the code for the water filtration methods, we are given a menu screen provided which filtration would you like to learn about. Selecting water filtration We then get a menu input asking us for select information regarding water filtration treatment. If we select our type as biosand and hit the select button, we are given a table provided the filter type, biological, organic, and inorganic, flow rate, useful life, unit, filter, labor demand, setup and use, and maintenance of the respective filter type. The menu now asks, would you like to learn more about filters? If we select yes, and this time select UV radiation and chemical treatment, but end up realizing that we want to go back, it will then provide us again re-asking which filtration would you like to learn about. If we now go to desalination and arsenic removal, select solar stills from the Excel file, and hit select, we are now given another table with the filter type and respective information given below. If we select no, we see that the filter information above will be reflected upon in the Excel file filter selection info. We are then given a menu input, select a filter method to test. If we select the Pureit, we are then asked an input, how many liters would you like to filter? Entering in 1000, we are given an advantages and disadvantages table. Given a chart, we can see the final cost at 1000 liters is $564.40. This will be a straight line displayed the cost per literage and the literage provided of the Pureit system. Down here, we are now asked would we like to choose a different filter. If we select no, we see that the selected filter information with their advantages and disadvantages will then be displayed on the selected filter to advantages disadvantages Excel file. Rerunning the program this time, if we select the X, we can see that we are now required to choose a filtration method without exiting the program. If we select water filtration, and this time select ceramic candle, selecting no, and then trying to close out of the select a filtration method to test, we see that it then again prompts us to select a filtration method. If this time we select the pure system and type in that we would like to enter in negative 600 liters, it will give us a warning showing us that literage was not a positive number, absolute value will be taken, and that the per system has now been calculated for 600 liters, giving us a cost of $480. Its advantages are listed and disadvantages, and if we hit yes this time, it will then ask us a new filtration method to test. Selecting safe water systems this time with 5.5 liters, we are then found that a decimal input is entered in for the cost per literage, and the literage shown to 5.5. If we then hit no, we can see once again the filter with their advantages and disadvantages have been displayed in the Excel file provided. And that is the water filtration code for our group project.
Our code is useful but limited. The first limitation of our code is that not all filter types are included. As stated before, there are many filter types. Our code only uses 26 of the many filter types. A second limitation of our code is that our cost only accounts for the cost of water filtration. It does not include the initial cost of the filtration system. Also, from the data that we found, not all the information is provided. For example, some of the filters did not provide a life expectancy of all the filters.